Thank you very much for the invitation to present our research. We just started this project very recently in July. So I'm going to tell you a little bit about the background story and the preliminary results that we have. This is still an ongoing effort. It is a collaboration with Swadesh Santra, he's chemical engineering in the University of Central Florida, and Lindsay Burbank, she talked earlier, another collaborative project in USDA ARS. And Deepak is my postdoc, and Jorge is a student with Swadesh doing the actual work. These are the 4 objectives that we proposed for 3 years of work, but we just started a few months ago. So the idea is to use chemical treatment for Xylella. As you guys know, the growers will be probably more willing to use something chemical that will be active against this bacterium than other approaches that are much more forward-thinking than a chemical approach. So why are we starting to work? We've been starting with these nanoparticles, and this is work that I've been involved in a collaboration with Swadesh Santra and other people for many years. And this compound, the one that I'm going to talk about today, that is called zincicide, a nanoformulation, was designed preliminary for citrus diseases, mainly for HLB and citrus canker. And it's been studied for, I would say, maybe 7 or 8 years already. And what is this zincicide? So zincicide is a micronutrient, zinc-based systemic bactericide, the definition. So this is pretty much a nanoparticle formulation that has more than zinc oxide, has other components that I'm not even aware of. But it's a formulation that makes these particles very small, as a protein size of 4 nanometers, was designed by Swadesh. And they've been doing multiple iterations of this formulation. And 2 years ago, a company in Florida, Trademark Nitrogen, started making this compound, big batches, and with agricultural grade components. So we've been through the process, and we've been studying different, testing different formulations. And you will see that the one I'm going to talk about today is called 110 and 111. So this is 111 times that this formulation has been changed. We didn't test it at 110. I don't know if you can see my mouse, but the interesting thing is that it's very clear, and the newer formulations are very stable. I'm going to go over what we have learned about zincicide. Just let you know that the most important thing for a practical point of view is the work that Evan Johnson at the University of Florida in Lake Alfred, the CREC, have done for the last maybe 5 years. He's been studying in the field application of this compound zincicide to control HLB, citrus green, that you guys know is a phloem-limited bacteria that causes this problem, Candida Helicobacter asiaticus. He's been doing this experiment in grapefruit and in Valencia oranges. And this is some results that he shared with me. He hasn't published this already yet, sorry. But basically, what you see here is the different, you guys hopefully can see my mouse, but the untreated control is the black line. This is the weight of the harvest fruit. And this is the different applications. So they apply this compound foliar, different rates in the soil, and also like a mixture of soil and foliar. This is again a phloem-limited bacteria. And they saw that there's an increase. And what I was more interested when we were looking at the data was like just applying in the soil, this compound was being active against this pathogen. And so this also was seen in multiple years, this effect. And the other effect that he has seen is the one on the left, if you guys can see. This is the fruit that he divided by the size, small, medium, and large. So the disease HLB caused a smaller fruit that they are unmarketable. So you can see that by applying also the zincicide foliar and soil, you see an increase in the medium and large fruits compared to the untreated control. So this all seems to indicate that it has some activity against this phloem bacteria. Another collaborator in this big group of collaborators is Laureen Tetar, also at UCF. She studied if she can follow the zinc level in the plant where they are treated with zincicide. And interesting for my Xylella point of view was that she looked at increasing zinc in treated plants, and she saw that the zinc was increased in the phloem, but also in the xylem when they applied to the plants, and not in the pith area. We decided to give it a try to Xylella, this compound, because as you guys know, Xylella is a xylem-limited pathogen. And of course, ideally would be to have an antimicrobial compound that can be delivered, but as you guys know, there's like hundreds of compounds that kill Xylella, but none of them can easily get in the xylem and be active in the plant. So we wanted to test if we could have some results using this nano formulation. We tried before with other things. First, we tried with copper, of course, because copper, as you guys know, is the most common antibacterial compound used against bacteria, mainly in the phytosphere. This multiple studies, but main take-home message was we apply copper to the plants as a drench. We don't see a decrease in disease. It's the opposite. We even see an increase in disease the more copper that we added to the plants. So you can see it's not significant, but that's what the tendency was, like the more copper in the drench application, the more symptoms we saw. So that was not very exciting from application, of course, but also we saw in bacteria. This is bacteria measure. She measured the total and the viable amount of Xylella in the plants, and a higher concentration of copper. There was more of the bacteria. We think, we discussed in the paper that we think that's because the bacteria form more biofilm. I know that Caroline mentioned that she doesn't think that biofilm is important for disease, but I still think that it's important for disease. And we have data showing that this copper at this concentration create more biofilm formation for Xylella fastidiosa. So, of course, we also look at zinc, but zinc as a zinc sulfate, a normal formulation of zinc against Xylella. And in vitro, we also saw that higher concentration of zinc, of course, is inhibitory for the bacterium. But to our surprise, when we did experiments in the microfluidic chambers, and this is a system when we have flow from left to right here, and what you see here is bacteria, that is Xylella, that is forming these aggregates, biofilms, in the microfluidic chambers with the normal media PD2. And when we added zinc sulfate, we also saw that response of the bacteria to form more biofilm, that is a defense response to protect against this attack of this chemical. So, of course, we never tested zinc sulfate in the plant, but we were discouraged for this to be as a possible control method. But when we started working with StratEdge with this nanoparticle, again, I'm going to talk first about this formulation called TMN1110 in red. We compared the activity against bulk zinc oxide, so just to say non-nano formulation of zinc oxide. This work was done in the right here. It was done by my student Ever on Liberibacter crescens as a model for HLV. And he defined the MIC concentration and the time to kill, how much long does it take. And then Deepak, my postdoc, he started working with Xylella, doing similar experiments. And interestingly, we saw that the MIC, minimal in this case, he measured the bactericidal concentration. It was more active against this compound, and it was killing the bacteria in less than 1 hour. This is all in vitro study. So we were encouraged to see what happened. And when he tested the microfluidic chambers, this is just a control with Xylella, and then with the zinc side, he saw that the amount of bacteria in the chambers were a lot less. And also, when he would measure the amount of bacteria that were in the reservoir, so like after the media goes to the chambers, he took the reservoir and played it to see how many bacteria actually are culturable after treatment. He couldn't find any. So we saw that, okay, this is active in vitro, but as I mentioned earlier, there's a lot of things that are killing Xylella in vitro, but they don't work in plant. So this cultural cell measurements that I showed the formulation TM1110 and the newer formulation that was just earlier this year, they made it early 21, seems to be a little bit more active. So it has activity, Xylella, but it's even more active. The MBC is about 40 ppm, when the other one was at 60 ppm. And of course, we started testing these things in the greenhouse. These are some of the preliminary results that we did first with tobacco. We first tried to see if this was active against tobacco by first checking if we have phytotoxicity, because this is a problem with chemicals. So this was all drench inoculation. And what Deepak did was like, he applied 4 times, once per week as a drench. And you see that at the high concentration that he applied, we can see in phytotoxicity. This is in tobacco, and this one was in blueberry. And these small pots and with the younger plants. And of course, then we learned that we had to give the plants more time to grow before we put so much of the zincicide. But interestingly, when we measure the amount of zinc in the leaves of the plant, so this is just an indirect measurement of how if the zinc has been taken by the roots into the plant, and then they are deposited in the top. In tobacco, we saw, as you guys can see, a significant increase at the higher concentrations of zincicide treatment. In blueberry, we could not. We just saw that there was no significant difference of zinc content. But then we tested against the different possibilities of this as a treatment to against Xylella. What you see here, this is progress curve. So this is different weeks of assessment, and this is the disease severity, and these are the AUDPC, and these are the measurements of the bacteria in the plant. So basically, these are the treatments that he used, different applications. At the beginning, we couldn't see when he used lower concentrations, we couldn't see any effect. So there was no really reduction in the disease outcome of the infection. But when he started doing this a little bit higher concentration, the more he added to the tobacco, we saw a significant decrease in the AUDPC. And you can see the higher treatments, we see almost practically no disease. And the bacteria, we couldn't find any Xylella. They were all gone. So we were encouraged by this. And these are some of the pictures of examples of how the tobacco looked like. Again, Lindsay showed some also pictures of tobacco earlier today. These are the treatment that didn't have any disease control. So you see a different range of applications of zincicide that still develop symptoms pretty well. But when he added these higher concentrations, there's no symptoms, so little symptoms. The one in red are the infection control, and the ones in greens are the application control, so just not adding zincicide or zincicide, but without infection. These plants are not infected with the Xylella. Then we did the same thing with blueberry. So the same thing, when he used low concentrations, there was not much activity, but when he added high concentrations, we didn't see such a dramatic control as we saw in tobacco, the model system. As you guys can see in AUDPCs, in blueberries, we saw a decrease and also decrease in the bacteria, but we still see, of course, the bacteria still there, but very low populations. And these are examples of the pictures of this is the infected control, and this is the control with no, these are not treated with Xylella, infected with Xylella. But again, these were done with bigger pots, with 1 gallon and 8 weeks old pots. So recently we received this new formulation, the TMN111, that we've been working with this since the summer, since we started this project. And the first thing we did was to repeat the phytotoxicity, but in this case, we tested with salt drench and with foliar spray. So this is one dose applications of different concentrations. And these are, again, pictures of tobacco plants. And you can see that with the foliar spray at higher concentrations, we saw quite a bit of phytotoxicity. But with drench at this concentration, we did not see any problems. Interestingly, Deepak noticed that when he was using even the other formulation, the TM110, the plants would look greener and better than the one not treated, and that's because of with this you're giving a nutrient that is zinc to the plant, and also the other components in the formulation that has a nutritional factor as well. So in this case, he quantified this is a chlorophyll, and these are non-infected plants. These are infected plants, and these are again the controls you see on the left, and then the higher concentration of the zincicide applied, and you see that the higher concentrations is higher measurements of chlorophyll. And as well, the plants were taller when you add more zincicide. So there seems to be also an effect of making the plants grow better with this nano formulation. When we look at the bacterial populations, again, the same thing. This is just a preliminary experiment with one application of 1 dose each time. We saw that again, this I mark here in red the concentration, where we saw a significant decrease and almost disappearance almost of the bacteria at these concentrations. This now he's just starting some new experiments, and we're gonna try to see more the activity of this new formulation against Xylella. And in parallel with Lindsay Burbank, Lindsay started testing these compounds in grapes. We started this project last July. She used grape seedlings, so she tested first the 2 formulations, the 1110 and the 1111. And what you see here, the weeks after the treatment, and these are the values, again, this color-coded of the untreated control, and then the high concentration of each. This was just like a single dose of zincicide each time. She saw the number of leaves and the plant height were increased at high concentrations of this, also in grape seedlings that she did in the greenhouse. And at high concentration of the TM1111, again, she started seeing some phytotoxicity. So we have to be careful not to reach the high concentrations in our experiments. And then she also did another experiment where she did weekly applications up to 6 weeks of salt drench, 250 ppm each one, the 2 formulations, the 1110 and the 1111. And again, she saw again the number of leaves were increased and the plant height will increase. And again, we are getting ready for next year with Lindsay, if we get extension of the funding, to start the experiments with infection of grapes and add Zincicide. So the preliminary results so far, again, so we show that Zincicide, these two formulations are very active in vitro under batch and flow conditions. In tobacco, we see like a good, very good control that is very encouraging of Xylella. So we see that they are taking up the zinc, they are killing the bacteria inside, they're reducing the symptoms. Something similar we see in blueberry, but we don't see at this moment a significant increase in the zinc. So we don't know if it's, again, the activity goes not only by directly killing the bacteria, but also causing something in the plant, some response in the plant, we are not sure. And this new formulation, we see it seems to be like improved in vitro activity, it's active in tobacco, and does not cause toxicity in grapes, and also it seems to have also like a positive effect on the growth of grape seedlings. So right now we are again testing different combinations of this TM111 with other nanoparticles that Swadesh has been working on, and we're just starting to do some experiments in vitro. We have not get to the plants yet, so hopefully by next year we can tell you something about that, and we're trying to attack the bacteria from different angles. Thank you very much for the opportunity to talk. These are the co-authors funding, and this work we started with some undergraduates in my lab and some other people that helped along the way. Thank you very much, and I'll be happy to answer any questions.
Thank you very much. We do have a few minutes for a Q&A here. So one question for you, Leo. Do you know if these zinc nanoparticle options would be able to be used in organic production?
I don't know. Okay, so all the components, as I mentioned, I don't know exactly the components that we have, but they are plant-based, so they are all like, let's say, natural components. It's zinc oxide, and I think it has some salicylic acid in there and stuff like that. So I don't know exactly, but I will assume it would be okay, but I'm not an expert on the conditions for organic.
That's fine. Yeah, I don't know if any of these products are on the market and certified, for example, for use in California at this point. That may not be the case yet. I had one also more of a comment from Carolyn Roper, just wondering if treatments aimed at disrupting biofilms and shifting populations, tonic state might lead to increased colonization and hypervirulence.
So the question is like if distracting the biofilm will cause hypervirulence?
Yeah, just wondering if that's a possibility.
Yeah, Caroline, I still feel like biofilm is important for infection. I know you mentioned the work of this work also that by Nabil and Rodrigo, when they showed that if you mutate the EPS, the bacteria cannot cause disease. So I feel like to have something that plugs the biofilm that is plugging the vessels, I know if it's the most important thing, but I think it's part of the infection process. So I think it's better to, usually biofilm is very important for insect transmission. And so something that will reduce the biofilm formation will be important not only for the disease in the plant, but also for the transmission by the insect. That's what I think.